All right, so for this test, we're going to be dealing with a lot of problems involving mixed numbers because that's what this unit was all about, was mixed numbers. So I figured we'd review what that means. A mixed number is a number that mixes up or combines a whole number with a fraction. Now keep in mind this fraction has to be a proper fraction, which it is here where the numerator is smaller than the denominator. If this was an improper fraction where the numerator was bigger than the denominator, then this would not be considered a mixed number. We would have to change it into a mixed number. So let's also look at the difference between an improper fraction and a proper fraction or a mixed number as well. So here we have this improper fraction 3 over 2. And we can see that it's improper because the top number is bigger than the bottom number. The numerator is bigger than the denominator. So if I have an improper fraction, I can always turn it into a mixed number. The way I do that is I think about how many times does my denominator fit inside of my numerator? Well, 2 can go into 3 just one time. So I can take out 1 as my whole number. Now, when I take 1 out of this, it's the same thing as taking out 2 over 2, right? 2 halves is the same thing as 1 whole. So I'm taking, or I'm borrowing, 2 of these 3 halves and turning them into 1 whole. Now, if I'm borrowing 2 of these 3 halves, then I have to take away 2 of them from the 3 to find out what's left over. And 3 minus 2 is 1 half left over. And there is my mixed number from this improper fraction. So 3 halves is the same thing as 1 and 1 half. So let's look at some problems that we can actually work with now. When I'm adding or subtracting mixed numbers that have like denominators, which means the denominators in both the fractions are the same, when I'm adding or subtracting mixed numbers like this, then I can just start off by adding the fractions first because I don't have to do anything to change those denominators. I can just start adding them. So 1/4 plus 2/4, that'll give me 3/4. And then I go ahead and I add the whole numbers, and 1 plus 2 is 3, and there's my final answer. 1 and 1/4 plus 2 and 2/4 is equal to 3 and 3/4. Now, what if I'm adding or subtracting mixed numbers that have unlike denominators, which means that the denominators are not the same? Well, if they're not the same, then we have to first change them so that they will be the same. Now, to change them, we're going to need to make our list of our 2 denominators. So our denominators are 2 and 3. And then we need to list all their multiples because what we're trying to find is what's the least common multiple between these 2 numbers that I could change both of those denominators into so that they will be the same. So 2 times 1 is 2, 4, 6, 3 times 1 is 3, 6, 9, and then I see right here I have a least common multiple of 6. What that tells me is I can rewrite both of those fractions that have different denominators. These 2, I can rewrite them as fractions over 6. Okay? So I have to think about 2 times what gets me to 6? Well, 2 times 3 gets me to 6. And if I multiply the bottom number times 3, I got to multiply the top number times 3. 1 times 3 is 3. Okay? And now I'm basically getting rid of that fraction because I rewrote it as 3/6. And 3 times what is 6? 3 times 2 is 6. If I multiply the bottom times 2, I got to multiply the top times 2. 1 times 2 is 2. So now I've rewritten 1/2 and 1/3 as 3/6 and 2/6. Now they have the same denominator, and I can just go ahead and add those fractions together. So 3/6 plus 2/6, that gets me 5/6. And 2 plus 1 is 3. And there's my final answer, 3 and 5/6. All right, what about if I'm multiplying mixed numbers? So instead of adding or subtracting, what if I'm multiplying them? Well, what we have to do when we're multiplying mixed numbers is we have to first turn them into just regular fractions. Right now they have fractions inside of them, but they also have these whole numbers attached. So we got to take those out and just rewrite these numbers as just plain old fractions. So here's how we're going to do that. We're going to take our number 1 2/3, and the first step we're going to do is we're going to multiply the denominator times the whole number. So we're going to do 3 times 1, which is 3, and we take that value, that 3, and we add the numerator to it. So 3 plus 2 is 5, and that's my top number, my new numerator. And the denominator is going to stay the same. So I can rewrite 1 2/3 as just 5/3. So I'm going to do that right here, 5/3. Now I'm going to do 2 1/4. I got to change that one. So I got 2 1/4. I'm going to start by multiplying the denominator times the whole number. 4 times 2 is 8. Then I take that value and I add the numerator, so 8 plus 1, that's 9. And the denominator stays the same, 9/4. So I'm going to rewrite that right down here as well. I'm using the same operation. Now, when I'm multiplying fractions, all I do is multiply straight across. So 5 times 9, that's going to give me 45. 3 times 4, that's going to give me 12. Now, I can simplify this 45/12 by thinking about what number can I divide into both of those numbers. So I can do 45 divided by 3, and I can do 12 divided by 3. That's going to give me 15/4. However, this is an improper fraction. This is technically the correct answer, but I want to change it back into a mixed number because that was the form of the numbers when I first started the problem. So I'm going to take 15/4 and I'm going to change it from an improper fraction into a mixed number. So I have to think about how many times will 4 go into 15 without going over 15? Well, I know I can put 4 into 15 3 times because that'll be 12. But if I try 4 times, that'll get me to 16, and I don't have 16/4. So I can borrow 3 whole, which is the same thing as 12/4. Right? I'm borrowing 12 of these 15/4 and turning them into just the number 3 wholes. Now, if I take 12/4 away from 15/4, I have to subtract that from the 15 that I have. And 15 minus 12, well, that's going to be 3. And the bottom number is going to stay the same. And there is my final answer, 3 3/4. So 1 2/3 times 2 1/4 is 3 3/4. What if I'm dividing mixed numbers? So I got 3 1/3 divided by 1 1/2. Well, just like when we're multiplying, I have to change these mixed numbers into just regular fractions. So I'm going to do the same process. I'm going to say 3 1/3. I got to start by multiplying the denominator times the whole number. 3 times 3 is 9, and 9 plus 1 gives me 10 as the top number, and 3 is my denominator still. So I'm going to write that down below. I'm rewriting the problem, 10/3. Then I got to work with 1 1/2. So 2 times 1 is 2, plus 1 is 3, and the denominator stays the same, 3/2. So I'm rewriting the problem 3/2. These are the same exact problem, they're just written different ways. So instead of 3 1/3 divided by 1 1/2, I have 10/3 divided by 3/2. It's the same exact thing. Now, to solve this problem, I have to use the strategy that we've talked about in class, flip switch. So I'm going to flip the second fraction and switch this to multiply. So I'm going to rewrite it right over here. I have 10/3 times, now this number is going to be on top, 2/3. And to solve multiplying fractions, I just multiply straight across. So 10 times 2, that's 20. 3 times 3 gives me 9. I can't simplify this, however, I can change it back into a mixed number. So I'm going to write it down here, 20/9. I have to think about how many times will 9 go into 20 whole times. Well, 9 will go into 20 2 whole times, and that's the same thing as 18/9, right? Because 9 times 2 is 18. So I'm taking 18 of these 20/9, borrowing them and turning them into the whole number, just 2. Well, if I'm borrowing 18 of them, I gotta subtract them away from the 20 that I started with. And 20 minus 18 is 2, and the denominator stays the same. There's my final answer, 2 2/9. All right, now let's change it up a little bit. Now we're going to just talk about approximate answers. This is where you don't actually have to do all the specific math and you don't need to get an exact answer, but we just need an approximate answer, which means we need something that's close to the right answer. So to do that, we're going to use a process called rounding. Now here I have the problem 1 1/12 plus 2 7/8. Now I could go through the whole process saying, well, I have different denominators, so I need to first find my least common multiple, and I'm going to do 12 and 24, and just keep going on and on and on. But I don't need to do this if I'm getting an approximate answer. My answer just needs to be close. I don't need to be exact. So here's how I'm going to do this. I see 1/12, and I think 1/12 is pretty small. It's not really going to change the outcome too much if I leave it in or if I get rid of it. So I'm going to round 1 1/12 down to just the whole number 1, because there's not a big difference between 1 and 1 1/12. There's not a huge difference. Now I also see 2 7/8. Well, 7/8 by itself is pretty close to 8/8, which is the same thing as 1 whole. So I can round 2 7/8 up to just the number 3, because I'm only 1/8 away from that. And if I add 1 plus 3, I get an approximate answer of 4. And that is much easier than doing all the steps like this. And we can still get close to the right answer, which is our approximate answer. So now let's go back and talk a little bit about tessellations. And we looked at MC Escher's artwork on his website where he used tessellations a lot. And so here we have a tessellation of triangles, and they've been boxed in. So we see the same shape being repeated over and over and over. And then we also see that the width of this rectangle is 1/2 inch and the length is 1.5 inches. We're going to use those values in just a second. Now, if I want to find the area of this tessellation, I want to find how much space does this tessellation take up. If I want to find that, I need to take the length and multiply it by the width. Well, remember my length is 1.5 and my width is 1/2. So I would multiply these two numbers together. Now, just like when we're multiplying mixed numbers, I have to first make sure they're both fractions. This one's already a fraction, so we can just leave it be. This one I need to multiply the denominator times the whole number. 2 times 1 is 2. And add the numerator. 2 plus 1 is 3, so I can rewrite this problem as 3/2 times 1/2. And when I'm multiplying fractions like this, I just go straight across. 3 times 1 is 3. 2 times 2 is 4, and so the area of the tessellation is 3/4. Technically it's 3/4 inches squared, but 3/4 is the main part to remember here. Now let's say I wanted to find the difference between the length and the width. Well, whenever I see the word difference, I have to think subtract. So the difference between the length and the width is how much bigger is this side than this side. Well, to do that, I'm just going to take the big side and subtract the other side. Well, this one's pretty easy. 1.5 minus 1/2 is just going to equal 1. I'm taking this half and I'm subtracting it. So I'm just left with 1 whole. Now, I also want to talk about how we can move or transform shapes. So there's 3 terms that we talked about when transforming shapes. So here I have my shape, And what I've done to it this time is I've done a translation, which is the same thing as saying slide. So I took this shape and I slid it to the right. I could slide it up or down, diagonally, whatever. But the main thing to remember is that the shape, the orientation, the way it's pointing doesn't change. You notice how the arrow here is facing the left. Well, it's still facing the exact same direction over here. All I've done is I've taken it and I slid it over there. I didn't spin it or do anything like that. Now, another thing we can talk about is rotation. Now I've taken this shape and I've spun it so that now the arrow is pointing up. So this is a rotation, and it's the same thing as spinning. Now the last one is a reflection, and this is basically the same thing as saying I flip the shape over. So here I take this shape and I flip it over so that now the arrow, which was facing left, is now facing the other direction, right. And that's everything you need to know for this test.